Hello students, welcome. Today we are going to start with a new chapter, that is runoff, and in this chapter we'll be studying the process overall, what runoff is. We'll also be studying the characteristics of catchment. We also be studying the factors that would affect a runoff in a catchment, and finally we will discuss various methods to quantify runoff out of a catchment. So with this, let's get started. So first and the foremost thing to understand here is, let's go and understand the basic terminologies that we will be using frequently hereafter. The first term we have on the list is the stream. As we all know, stream is a natural flow channel. Okay, the water has a tendency to erode the land surface and form it into a channel so that it can flow easily. So that is what we call by streams. And all the natural stream like Wangchu, Punachangchu, and all the rivers that we have, if you see, it will have a kind of a parabolic shape. The bathymetry of a stream is kind of a parabolized because it has a tendency to erode the material and form into that channel, and we call it as streams. Okay, and next term on the list is overland flow. What happens is, as soon as there is a rainfall, and when the rainfall intensity exceeds the infiltration capacity, then the runoff starts. But the first thing, as it does not start as a stream, it will start as a sheet flow. You must have seen, if you spill water on a ground or in a concrete floor, you will know that water moves in a sheet form, and that is what we call by overland flow. You can observe this overland flow in any parking lot or in a huge paved surface. As soon as there is a runoff, there is no infiltration as such, so it will start to flow, but it will not start to flow as a stream, but it will start to flow as a sheet, and that is what we call by overland flow. And the surface runoff accounts for all the the runoffs that is generated from a catchment surface. Okay, so eventually this runoff will get into a stream and it will flow downstream. So that is what we call by a surface runoff. Now what happens is, the next term is the surface runoff or the interflow. Here what happens is, as soon as there's a rainfall, as I explained, there's infiltration. So some portion of water, it will infiltrate into the ground, but it will start to move laterally. Okay, laterally means, if there is a, let's say there's a mountain topography. Okay, so if there's a rainfall here, what happens is some portion of water gets into the ground, and instead of going further deep, okay, it starts to laterally flow, and at some point of time it will again come out. Okay, I have recorded a video where it can be clearly visualized the subsurface flow. It was a landslide area, and on that surface the portion of land has already been washed out as a landslide, and from that portion it is clearly visible that interflow. So this will eventually come out at some point downstream, and again it will flow down and finally get into the stream. Okay, so that is what we call by the subsurface flow or the interflow. Usually in our analysis, this interflow is, the quantity of interflow is so less that we tend to ignore this. Okay, so before we further go into the understanding terminologies that we will be using frequently in this chapter, let's understand the rainfall or the runoff as a process. So after that, we are going to study this, the other terminologies, because it's important for us to understand the process. So let's start with the rainfall. So as you can see, the first diagram, see, this is what we have studied in the previous chapter, right? The infiltration concept was discussed using a heatograph, right? So when there is a rainfall, and rainfall can be represented for analysis, it can be represented as an heatograph or a column graph. So as soon as there's a rainfall, there's a losses, right? And these losses can be modeled with some infiltration curve, and we have studied that we have Horton's curve, and we have Kostyukov curve, we have Phillips curve. These are the models to model the infiltration. So when you plot the overlap the infiltration curve on the rainfall heatograph, the portion that is below the infiltration curve is, these are the amount of rainfall that is infiltrated in the ground and is not available as a surface runoff. So whatever is remaining is what we call by effective rainfall. So okay, so I've already written it here. So this is what is known as effective rainfall, and this rainfall eventually gets into a stream and starts to flow down. Now graphically, now let me first draw a catchment. Okay, this is the stream. Let's say there's a stream, so these are these branches. Okay, so these are the branches, and here it has the ridge. So okay, so let's say there's a stream. So what happens is, if you stay here with some measuring device and start to measure discharge with respect to time, you're going to get something known as hydrograph, and this diagram is what we call by hydrograph. Okay, so it is a discharge versus time graph. Now to understand this graph, initially when there is a rainfall, it will take some time for this rain to get into stream and then flow down the stream, right? So initially when there is a rainfall, the level of water remains almost the same, and gradually it will rise. This rising is dependent upon the catchment characteristic. If the catchment, the slope of this catchment is very steep, like in our case in the mountainous topography like in Himalayas, this tend to become very steep. Okay, this tend to become very steep. But if it is a relatively flat topography, the catchment, I'm talking about the catchment overall slope, if it is relatively flat, then this will have very gentle rising. Okay, it will be a very gentle, and it will finally reach a peak, and then this means that the entire catchment has now contributed its the runoff at the outlet, which we call it as mouth. Sometimes we refer to this as a mouth. So this point refers that this is from all the remote location, the rainfall has now reached to this point, and then what happens is it will start to gradually the discharge will gradually decrease, and finally it will reach the normal position, normal whatever it was there. Okay, but if we look deeper into this hydrograph, the hydrograph is composed of two parts. One is the base flow and another one is the direct flow. Okay, direct runoff, we call it this DIRECT, direct runoff. Now like I said, whatever we see on the top of the on the surface, okay, this what we call as direct runoff. This rainfall gets into the stream and then it starts to flow here. That is what it is visually, you can see these things, right? But what happens is some portion of water infiltrates into ground, and these also starts to flow, as I explained, laterally. Okay, some rainfall may come out at the catchment surface again, but most of it flows as a groundwater flow, and it will again contribute here directly at the mouth, but you cannot see this, and that portion is what we call by base flow. Usually in our analysis we have to find ways to remove this base flow if we are only analyzing the direct runoff. So we will discuss about how to remove this base flow from a hydrograph in subsequent chapters, but for now just understand that hydrograph consists of a rising limb, a falling limb. The rising limb and a falling limb, the characteristic of this curve depends upon rainfall characteristic as well as the catchment characteristics. And if you look closely with in the hydrograph itself is composed of two parts, that is the base flow part and the direct runoff part. Base flow part are those portion of runoff that is not through the surface, but instead it is the groundwater that is contributing the flow. And so direct runoff is the part of a runoff that is seen on the surface. So direct runoff means it is flowing over the surface and it's directly contributing to the channel outlet. So these are the few terminologies that we must understand here. Okay, so basically that is what I have explained here: stream flow and direct runoff, like I explained, and the base flow. the delayed flow that reaches a stream essentially as groundwater flow. That is what I have explained here. Okay, so here same thing is written in words, so I want you to go through it, okay, with some more details on the hydrograph. Now let's discuss about the various types of streams. Okay, the streams can be perennial. Perennial means there will be water throughout the year. Okay, like Wangchu, you will find water throughout the year. Okay, intermediate streams are those streams, you know, where there's a limited groundwater contribution, which means during lean season this stream dries up. Okay, this stream dries up during the lean season because there is no contribution from the groundwater. Now if you take example of Amochu and Omchu, okay, Omchu is the river which is commonly known as the Dotikola in Phuntsholing, okay, that if you observe its characteristics during summer, because of the rainfall we receive a massive rainfall, so the volume of water is very high, but in winter it almost dries up. I mean, water is there but it almost dries up, so we can consider that stream as the intermittent streams. Okay, but the Amochu is the perennial stream. You'll always find huge volume of water running through the channel of Amochu. And there are ephemeral streams which has no contribution from the base flow, which means if there is a rainfall, there will be in the water, there will be a stream. If there is no rainfall, the stream will dry up. In southern Bhutan it is very common. Okay, if you go towards Galifu side, the Bhur and the, if you move towards the, you know, from Galifu, if you move towards Bhur, you will have plenty of these streams. Okay, this ephemeral stream. If there is a rainfall, there will be water in this channel. If there is no rainfall, the water immediately dries up. So that is because there is no contribution from the groundwater. To sustain the flow when there is no rainfall, there has to be some source, right? So this source is usually the groundwater. So if there is no contribution from the groundwater, so as soon as there is no runoff, the stream dries up. So these are the basic differences of the types of the stream, and we have three, okay, perennial, intermittent, and the ephemeral. Now there are other types, okay. So these are the previous type was this type we discussed about the whether the water exists in the stream or not by that sort of classification. Now what we are going to discuss is what is the source of this, you know, water. So it could be influent stream or effluent stream. In an effluent stream, which is also known as the gaining stream, groundwater contributes to the flow. You can see that from the diagram, is very clear. And effluent stream, the channel contributes to the groundwater. So this is the influent stream. Okay, so there are two types. Okay, now let's discuss about the factor affecting runoff. So broadly we can classify this factor into two groups: climatic factors and the catchment characteristics. We can also have third one that is not included here, but all the literature that has been published till that they don't include this as a third topic. But now from here on, what people are saying is that there can be third factor, that is the human. We have made so much of changes that it can affect runoff. Okay, we have constructed the paved land, we have constructed roads. Now because water is damaging our road, we have diverted the water into somewhere else. So we are manipulating the catchment to an extent that the entire runoff characteristic of a catchment is getting changed. So here can be humans, so we are the culprit here. Okay, so if we go by the climatic factors, the rainfall intensity, the rainfall duration, the areal distribution, these are the factors that can affect the runoff. Now catchment characteristic, the basin size, basin or catchment, these are the one and the same thing. Okay, and the basin shape, the basin slope, and drainage density, topography, and the infiltration characteristics. We also call this as geomorphological characteristics. Okay, this basin geology and this factor together, we can call it as basin geomorphology. Okay, so as a homework, why don't you give your own ways how the slope of a basin affects runoff characteristic. So let's take two example. Let's say there are two streams, very identical streams, okay, very identical streams, and their catchment area is also same. Let's say this is 100, this is also 100, okay, but the slope, this is quite relatively flat slope and this is the steep slope. So how would the runoff characteristic be? So runoff characteristic means the hydrograph at this outlet. So what you think, you can write your interpretation. Okay, so that is your homework. By the way, I have given the what is expected here. Okay, so you can read, understand, and try to explain in more detail in your own words, although answer is provided here. Okay, so try to explain in your own words. And also the shape, you can see here, okay, the how catchment shape affects the runoff characteristics. So if the streams are in radial fashion like this instead of branching, the shape is expected to be somewhat in this fashion. Now if there is an elongated catchment means it is not fan like shape, but it is, you can see the other stream, the secondary streams are very short and it contributes directly to the main stream. Yes, and the catchment is very kind of elongated. So from this catchment, the runoff hydrograph is somewhat like this. So it will have a quite a large, the peak is quite large compared to this radial pattern. And likewise, if our catchment is divided, so we can expect two major peak here from this at the outlet. So this is how catchment characteristic affect the runoff characteristics. So as I was saying, how the human beings have altered the catchment and how it is changing the catchment runoff characteristics. So you can see there is natural ground here. Okay, it was, let's take two conditions. One is natural ground and number two is impervious surface. Impervious surface means on the same ground now people have already paved with concrete and now it is made impervious. Okay, so what happens is initially when there is a runoff, there will be infiltration in this condition, and the hydrograph will gradually increase. Okay, increase because large volume of water is getting infiltrated. Its peak is going to be lower than the condition 2, where it is all the rain that has come fallen over this surface flows as a runoff. So it will again have a very sharp rise, and the peak is going to be comparatively is going to be the discharge is going to QP is going to be more than the QP of condition 1. That's because the volume of water, all the volume is getting contributed as a runoff. In the first scenario, majority of the water, the volume is getting most of the volume, I mean, let's say not most, let me put it this way, so some portion of the rain is absorbed by the ground. So here the peak is going to be less. So that is how we humans have modified our catchment, and that is the effect of the catchment. Okay, that is the effect because of the changes brought to the catchment to the runoff characteristics. With this, now let us quickly discuss about some catchment characteristics. Okay, there are a few catchment characteristics terminology. I'll simply run over it because it's very straightforward. Okay, now as we have seen, some catchments are really elongated, right? Some catchments are fat, like a fan shaped. So how do we distinguish this kind of catchment? So we need some parameters to distinguish between this catchment so that we can analyze better. Yes, so these catchment characteristics are a mathematical parameters that can distinguish the catchments. So now we have, let's go one by one, what are the various characteristics. So first one is the drainage density. So it is the total length of all stream to the catchment area. So you add this length and total length divided by the catchment area, you get the drainage density. Okay, so obviously the drainage density for a fan shape is going to be much more higher than elongated one, because here the water has to travel a way longer distance, right? And the area, if the area is somewhat similar, then of course here it's going to be, the drainage is going to be higher. But that depends, right? That depends. That's why to distinguish the characteristics we have this drainage density. But basically, if the drainage, the distance, the travel distance or the length of a stream is more, the drainage density is going to be higher, right? Now stream density, number of stream of a given order per square kilometer. Now what is this stream order we are going to discuss next? Okay, so it is the number of stream orders per square kilometer. So we'll discuss what is this stream order next. So here we have the stream order. So stream order means the branching of stream, and we follow the Horton-Strahler type of stream branching fashion for our analysis. And there is another one, Shreve, the scheme of Shreve scheme. Okay, so the basic difference is the first order that does not have any branching, we call it as the first order stream. That is, that definition for first order is same for both Horton and Shreve's. Horton-Strahler, this is same thing, okay, or the Shreve, S-H-R-E-V-E, Shreve. Let me pronounce this as a Shreve. Okay, so the first order definition of a stream is same for both the cases. Now the second order is also going to be same, because when two first order when two first order joins, then it becomes second order for Horton. And when one second order and the first order joins, the stream order does not increase in the Horton's case. Okay, so for instance, if two stream order second and first order joins, the stream order of the joint river will be the stream order of the higher stream order. Okay, but if 2 and 2 gets connected, then we get 3, so it gets one stream order higher. Whereas the case of Shreve is quite different. Okay, here you simply add things, so 1 and 1 becomes 2, 2 and 1 becomes 3, and see, 1 and 1 becomes 2, 2 and 1 becomes 3, 3 and 1 becomes 4. Now 4 and 3 becomes 7. So it's very, you simply go on adding the stream orders. So that is how Shreve does it. And for in Horton's case, when two of similar magnitude stream order connects, then one higher stream order is formed. If lower stream is getting connected to a higher stream, the order does not change. So that is the difference. Okay, you just have to understand that much. And what else we have? We have the shape factor. It is the ratio of square of watershed length to watershed area. Okay, so if you, this ratio is what we call by the shape factor. And channel slope, very straightforward, slope of the channel. How do you calculate the slope of the channel? So let's say this is the longitudinal profile, right? So elevation here, and this distance, that will give you rise over run, right? So that is the average slope. So that is what is done here. Basin centroid. So basin centroid is all center of mass, right? That is the centroid. And there is form factor. It is the ratio of watershed area to square of the length of the longest stream. Okay, again one more parameter. Compactness coefficient, the ratio of perimeter of basin to the circumference of a circle with area equal of the basin. So that is how we calculate the compactness coefficient. And elongation ratio, circularity ratio, so these are also the parameters. Okay, so let's end our lecture with a simple thing. You can see that I have already delineated the catchment of 3 rivers. This is our Omchu, by the way. Here we are, this is CST. Okay, this is Omchu, This is Varsa river in Pasaka, and there is also one more river commonly known as Bhalujoda river. Okay, so I have already delineated 3 catchments, and I want you to do the same. I have you can click on this when I send you this file. You can click on this. Okay, link is embedded in this word here. Okay, there is a link here, and I have also attached the YouTube tutorial how to do the catchment delineation. So it is going to be very interesting. Okay, you try it, just 30 minutes. It will take no more than 30 minutes. So download the dem. You may not be able to open this dem on your cell phone, so download in your computer. Install QGIS. I have done this in QGIS. It's a free and open source software. Okay, so download this. Download this. This is the only data required. Okay, watch this tutorial and follow along with this tutorial. You should be in a position to get these 3. So I have given you whole dem. Okay, so all the processes that needs to be done with the dem is already done. You simply follow the tutorial and you should be able to do this delineation. So with this, let me end the lecture for now, and we shall continue the next part in the next video. Thank you.